Might want a calculator, and by might I mean grab a calculator. There's new ones up there. So far, when it comes to our postulate sheet, which is where we're going to start today, we've got limited stuff filled out on it. We've got the first two things filled out because we talked about them back in 3.1. The linear pair postulate, which says if you have a linear pair, those angles are supplementary. And vertical angles, which says vertical angles are congruent. Now, on that postulate sheet, notice that it says that those will come from a diagram. Just re-emphasizing that point. So, on a proof, if you see a picture that looks like a linear pair or a picture that looks like vertical angles, then you've got these things you can use. But, last week, Friday, we introduced these items here. We filled them in on our notes packet, though. But there's going to be an advantage on having this stuff filled out on the postulate sheet rather than just the notes packet, because as we move forward with chapters, we are going to be reusing many of our postulates and our theorems. So, as a result, having those in an easy to get to place is important. And furthermore, when we get to, say, the Chapter 5 test, you don't get to use the Chapter 3 notes packet on it. You will get to use the Chapter 3 postulate sheet, though. So, making sure we have our postulate sheets filled in is going to be important. If you missed filling in the full Chapter 2 postulate sheet back in Chapter 2, a full filled-in form of it is on Schoology already. Chapter 3 postulate sheet, a full filled-in form of it will be going up on Schoology today. But, in the meantime, let's get it filled in. So, filling in the rest of our postulate sheet means filling in these 4 theorems. Now, notice that these 4 theorems, the information on top says this is the stuff you know given that you have parallel lines and a diagram. So these ones are going to work with both. First one is corresponding angles postulate. If you have parallel lines, then corresponding angles are, does anyone remember, are they congruent or supplementary for corresponding? Congruent. So, by the corresponding angles postulate, CA post. Ooh, for some reason I don't have these filled in. That was VA theorem. That was LP post. I believe we filled them in. I had to make a new postulate sheet. But CA post, corresponding angles postulate, says that our corresponding angles are congruent. Now, corresponding angles, they are on the same side of the transversal, and they're both in the same relative position compared to the lines. Essentially, one of them is an interior angle, one of them is an exterior angle of the 2 lines crossed. In this case, of the 2 parallel lines. So, that would be like angle 1 and angle 5. So, corresponding angles postulate allows me to say angle 1 is congruent to angle 5. Or, I could say angle 2 is congruent to angle 6, because that's corresponding angles. Or, I could say angle 3 and angle 7 are congruent. Or, the last option is angle 4 and angle 8. Remember, corresponding angles have the most pairs in a picture that looks like this. Also remember, this only works if lines are parallel. All 4 of these only work if lines are parallel. Hence, it has if P is parallel to Q in the if. Okay, Alternate interior angles theorem. AIA theorem. What does alternate tell me about the angles? Do you remember? Not that it's altered, that they're on alternate sides of the transversal. They're on opposite sides of the transversal. Since our transversal here is the one that's the most vertical, it's not truly vertical. One of them's got to be to the left, one of them's got to be the right. Interior means they're between the parallel lines. So, angle 3 and angle, if I go across, I have either 4 or 6, but which one's the alternate interior? 4 or 6? 6. 3 and 4 are right next to one another, and if they're right next to one another, if they share a vertex, they would be like a linear pair, or if they share a vertex, they could also be like vertical angles, like 2 and 3 are vertical. But, so 3 and 6 would be the alternate interior angles, and alternate interior angles are also congruent. 3 and 6 are alternate interiors. What's the other pair of alternate interiors on the picture? Nope. 4 and 5. We also have alternate exterior angles. Alternate exterior angles. Alternate means opposite sides of the transversal. Exterior means outside of the two lines that were cut by the transversal, in this case the parallels. Would be something like angle 1 and angle 8. Has to be the other side of the transversal, so on the right side of it, and exterior. So in this case, 8. Alternate exterior angles are also congruent. 2 and 7 would be the other pair. Okay, consecutive interior angles is the last one. Consecutive interior angles theorem. Are these ones congruent? No, do not write that they are congruent. Consecutive interior angles. Consecutive means same side of transversal. Interior means inside the two lines cut. Would be like 3 and 5. And they are supplementary. Angle 4 and 6 is the other pair. Now we have all our information about our angles on one sheet, and that is going to help us as we move forward. Okay. So, at this time we're going to switch over to our notes packet. And we left off on page 8. Yeah, PG. So, stuff we do today is going to look a lot like the stuff that we did last week, Friday. Identify the angle relationship, solve for the variable. We have 6 angle relationships on here to work with. So, when it comes to, actually technically we have 7 angle relationships, only 6 are on the sheet. The other one is talked about back in chapter 2, actually in chapter 1. Okay, anyway, when it comes to identifying these angle relationships, their importance based on if they have parallel lines or not is going to be important. This first picture. Are there parallel lines? Yeah, that tells me that most likely, not necessarily, but most likely it's going to be one of these 4 setups. If you are struggling to identify angle pairs, Compare the location of those angles to the location on this picture. These two are located in the same place as kind of like 3 and 5 are. Look for 3 and 5 in these lists. And that can help you identify the angle pair if you're struggling. They are CIA. So that's the first thing it wants. So what is the angle relationship? And then it wants you to solve. From there, solving is dependent upon what the relationship between CIA angles is. And CIA angles are... No. Supplementary. And supplementary means they do what? Add up to 180. 31x minus 4 plus 14x plus 4 equals 180. Technically, in a proof, I'd be skipping over some steps right here, and I would need to deal with them. In fact, I'd be skipping over 2 steps to write this out, but that's not the point. We combine our like terms. 31x and 14x, we put them together and we get 45x. Negative 4 and a positive 4 go together and we get 0 equals 180. Mariana. In a proof, though, we wouldn't have said combine like terms. What would we have said for a reason? Starts with an S. Simplify. Okay. How do I get x alone? Divide by 45. 4?
Yeah.
There we go. So far looking familiar? Okay. Problem 2. Do you see parallel lines? Which means I'm not asking you to solve using corresponding alternate interior, alternate exterior, or consecutive interior angles. It doesn't mean you can't have those types of angle pairs. It means you can't solve using them. So, then I think, okay, do I have a linear pair or do I have vertical angles? I don't have an X with the 2 angles across from it. They're right next to one another. They are adjacent because they share this middle line. Are they a linear pair? No, because the parts that they don't share, this one and this one, don't make a straight line. And we've dealt with that before. We dealt with that back in 3.1. Next to one another, sharing that middle ray. I already said it. No, they're not equal. They do add up to 90 degrees, but what's their angle relationship? I already said it earlier. It starts with an A.
Adjacent.
They're adjacent. If they are sharing that middle ray and that vertex, they are adjacent. And adjacent angles, what we can do with them is what's on our first postulate sheet. It looks like this picture. Now this picture doesn't tell you what angle pairing there are, but this is adjacent angles. And adjacent angles you can add together to make the big angle. And the big angle, as was already pointed out, since this is a 90-degree angle, that means this is a 90-degree angle, is 90. Again, I would be missing some steps in the proof, but this isn't a proof. Jada, if I want to solve, what would you tell me to do now? Simplify, and what would we get? Hint, there's a 5x.
40.
Plus 40 equals 90. And that would be simplify. Leo, what would you tell me to do then? Subtract the 40 from both sides. Remember in the proof, the actual step is the 5x equals 50. It's not the little minus 40s. Aiden, you'd finish it off by telling me to do what? Divide by 5. Again, the step is not the divide by 5. The step is x is equal to 10 in the proof. Okay, question 3. First thing I'll look at is, do I see parallel lines? I see some parallel lines, so I might be using those angle pairs. Parallel lines doesn't guarantee I use them either, but it makes them more likely. Do you also notice that there's an excess of lines in this picture?
Do we not need the one that's going to the right?
When I outline those angles, they tell me which one I don't need. Which line do I not have anything written on?
The one on the right.
The one that's going kind of diagonally off to that right. This one is not there to be helpful. It's there to mess with us. So we ignore it. Okay? If I'm using these angle pairs, I can use the picture to help me out with locations, or I can ask myself, are they on the same or opposite sides of the transversal? Opposite. Are they between the two lines, outside of the two lines, or one of each?
It's AEA, right?
Outside. Outside and on opposite sides is indeed AEA. Alternate exterior angles. And according to the alternate exterior angle theorems, if I have parallel lines, alternate exterior angles are congruent. Fancy way of saying they are? The same or equal. Piper, if I want to solve, what would you tell me to do? Add this 2 to both sides?
Yeah.
Specifically, it would add to the 2, right? Okay, so I get 41x equals 39x plus 4. Diego, then what?
Wait, what? Doesn't it cancel out that 2?
Is 2 plus 2 0?
Oh, never mind.
That is a common mistake. That's why I did this problem. Be careful. It doesn't automatically cancel out. Diego, what would you tell me to do next?
Subtract the 41. Right or no?
Which one should I subtract? The 41 or the
39.
39? Okay. Yes. Yes, I would subtract those two, but I want to be picky about which one. Okay, I get 2x is equal to 4. Jasmine, how do I finish it? Divide by 2, x equals 2. Okay. Question 4. Do you see parallel lines? Yep. I know they're parallel because they've got the little triangles. Not just because they look parallel, they need the little triangles. Okay, and if they are parallel, I'm thinking probably using this type of angle pairing. If I'm using this picture to kind of help me identify, then I need to spin the picture so that the transversals go in the same way. It would be like angle 6 and angle 2 would be location-wise, where it's kind of lined up. 6 and 2 together is here. They're corresponding angles. Do you have to do it that way? No, I don't care which you use. If you use the picture or if you say, what side of the transversal, interior, exterior, one of each. I personally do the latter. Some of y'all are not there yet. Corresponding angles, congruent or supplementary? Congruent, aka equal. 131 equals 4x plus 3. Cam? Cam? If I want to solve, what are you going to tell me to do? we get?
128.
128 equals 4x. Peyton, what would we do next? Divide by 4. 32?
Yep.
Sweet. 32 is equal to x. I don't generally like it that way. I want to flip it around. Nate, what property allows me to flip it around?
Symmetry.
Symmetry. The symmetric property of equality. Okay, question 5. Do you see parallel lines?
Yeah.
Okay, makes me think I'm looking at these type of angle pairs. But if I line it up and I try to find these type of angle pairs, I'm looking at angle 1 and angle 2. I don't find 1 and 2 in here anywhere. So that tells me one of two things is happening. It tells me either it's an older style angle pair or it's an angle pairing that doesn't fit one of those options and we're going to have to manipulate to get there. To determine if it's one of my old style, my linear pair, my vertical angles, or my adjacent, determine that, the first thing I look at is, do they share a vertex?
Yeah.
Yeah. They share this vertex. In fact, if I look at the angles, there's one angle, there's the other angle. They not only share a vertex, they share this middle ray. All of this information is there to throw us off. Those are a linear pair. They share that middle line, and the part that they didn't share created a straight line. And linear pairs are supplementary. In other words, adding up to what number again? 180. Jackson, if they're adding up to 180, what does the equation look like?
9x plus 14 plus 9x plus 4 equals 180.
Good. I combine my like terms, I get 18x plus 18 equals 180. Combining like terms is what in a proof again? Anyone? Simplify. Subtract 18. 18x equals 162. Divide by 18. X is equal to 9. Got 3 left. Question 6, do you see parallel lines? No, means I'm not looking for corresponding consecutive interior, alternate exterior, at least not for solving. They can exist, but they don't work to solve.
It's adjacent.
Why is it adjacent, Nate?
I don't know, it looks like the same way we did on the other side. It's adjacent.
You're right. They share this middle ray, and the part they don't share does not make a line. That's why it's adjacent. And adjacent angles, the only thing we know about them is the little one plus the other little one makes the big one. Now, I'm purposely doing a lot of adjacent angles that have this other feature to them, and that is what the big angle is.
90 degrees.
90. Because I need you to look for that in the picture. Other times, adjacent angles, similar to what you saw in 3.1, they'll give you the picture. I can almost write a B, apparently. It's a good thing it's not in my name anywhere as Brittany Benson.
No, totally not.
Other times they'll give you the picture and then they'll say something along the lines of measure of angle BAC equals blah blah blah, and measure of angle CAD equals blah blah blah, and measure of angle BAD equals blah blah blah, and they'll tell it off to the side. But adjacent angles, you're always doing angle addition postulate. Little plus little equals the big one. 44 is a little, 3x plus 1 is a little, the big angle's in the 90. Combine my like terms, in other words, simplify. I get 3x plus 45 equals 90. Subtract the 45, I get 3x equals 45. Divide by 3, and x is 15. Question 7, do you see parallel lines? These ones look parallel, right? Can I guarantee they're parallel?
No.
And you don't think they look parallel either?
They do, but
They do, but unless you see the parallel symbols, it's not helpful to you. Or you'll see words that say they're parallel. There's nothing saying they're parallel, which means I'm looking at the old style, and I was already told that they are what kind?
yeah.
Vertical angles. Because they're across from one another on an X forming. This and this were there to throw you off. Vertical angles, congruent or supplementary? Congruent. 2 plus 4x equals 86. Minus the 2, 4x equals 84. Divide by 4, x is 21. I'm going through the solving quickly because of the fact that that's not, well, it's a key part of what you're going to do. It's not the new learning. Last problem. I don't see parallels. I'm not thinking I'm looking for anything new. I look at my two angles. One of them's this one, the other one's this one. Do you notice they're sharing the middle ray?
Is linear.
The part that they're not sharing is creating a line, so it is a linear pair. And linear pairs are congruent or supplementary. Supplementary. They add up to 180. Combine my like terms. In other words, simplify. Add the 8 and divide. Divide correctly, unlike what I just did. That's better.
Monday and Friday, you're okay.
It is a Monday and a Friday for me. Nothing too scary about today? Okay. Got a worksheet for y'all today. Today is the 14th, which means our 3.1 worksheet's due today. Our homework. Now here's one of the big problems about y'all having a 5-day weekend. I give you 2 school days to turn homework in. 2 school days from now is what day? There's no school Wednesday. Monday.
So that's when the unit ends?
That is not when the unit ends. The unit ends next week, Wednesday. But do not wait until Sunday to do your homework. You've got over a half an hour to do it in class. Use your time wisely. Okay, I am going to be gone tomorrow. Please be wonderful for the sub. Tomorrow there's going to be a couple things. There's a mini lesson. I think the mini lesson is like at most 15 minutes. I think it's less than 15 minutes though. It is a video that's essentially stuff we're already doing, and there's a quiz tomorrow. after Mariana. I believe the postulate sheet itself is actually already filled out on Schoology. Today's notes? When I saw initially you weren't filling out the postulate sheet, that's why I said it.
How are we doing?
I just have a question. Is this like a new prompt or is it the same?
Nope, it's the same, but your image might have more information on it than you need, so. Like, exactly. So look at that, when you're figuring out what you got going on.
Was I? Do we have another worksheet? What is it on this?
So leave your
You
phone
got
in
it
here.
turned in already.
Grab your chapter 2 notes and postulate sheet and a calculator.
Yeah, right.
Yeah, this is this.
Aiden, when you planning on finishing your test? Are you able to, like tomorrow during connections, we have storm study. We don't today, unfortunately. They messed with things. Would tomorrow during connections work? Okay. I will make note to sub.
Outside on this side and one outside on this side, so which one is this? Yeah, so you're making it two parallel lines. We've got one out here and one out here, so that'd be like. your
Did you
two
end
parallel
it
lines,
too?
one out here and one out here. So. Exactly.
Okay.
So what do you do with them?
So there's a couple options. Option 1, the obvious. It didn't actually get turned in. It's somewhere in your folder. Always double check that. Option 2, you forgot to put your name on it. And it's in the no name things behind the active board, so check the no name pile. Option 3, I screwed up. If I screwed up, one of two things should have happened. Either it's in my turn-in pile and I will be giving it back to you, in which you say, Benson, you screwed up. Or I've already handed it back to you. At which point, you should have said then, Benson, you screwed up. Now, if you still have it, and I screwed up, you just show it to me and, hey, Benson, you screwed up, and I fix it. If, on the days I hand it back to you, in which I've told the entire class, make sure that it's in the grade book and you didn't and you threw it away, I'm gonna say tough luck. One assignment's not gonna count. So, I will check my pile. If you check your stuff in the notary pile.
Well, Miss Benson, when you're done, could you please help me out? 'Cause
I probably could. Yeah, of course. Looks like 2.6 worksheet 2. It looks like 2.6 worksheet 2 is the one that you have marked. 2.6 worksheet 2. That's Peyton, that's Hayden.
Supplementary adds 180, right?
Complimentary adds up to 90. Supplementary is 180. You throwing things away.
It went into the recycling. It disappeared. Hold on.
I think I get most of these set up.
To mess with you. Yes, you would be after Diego. Diego, did you ever go? Or are you making pass now? Got it. I do not have it amongst my things. So Jada, it would be amongst your things. Okay, and Zion, you asked me to come over to you?
Yeah, so if I have two problems on the inside, is this consecutive period equals?
No. They're not consecutive interior. Do you see parallel lines? Which means I'm not gonna be asking anything about this, at least regarding solve. It is gonna be either vertical angles or linear pan, or they'll be adjacent, as in like right next. Same. These lines, Zion, are not extra. Those are parts of the angles. You got that angle. And you got that angle. I noticed they shared this with me.
Yeah.
Now
Is
these-
this one on here? No.
They're angles, they're not lines.
So that would be like your pair posture?
Not a linear.
Adjacent?
This is adjacent, because while they share the middle line, just like a linear pair does, the part they don't share doesn't create a sixth line. That's what's required for linear pairs. They share the middle and then the other part.
Oh, they have to share a single line to be a line here.
The linear pair, yeah. These are adjacent. And adjacent angles isn't on there. Because adjacent angles is something we did back in chapter 1 and in chapter 2. So in on your chapter 2 postulate sheet, there will be adjacent angles.
Okay.
And, it doesn't say adjacent angles, but it does tell you to do the angle addition postulate.
So this would be like the same one, cause this one's on here and this is on here.
This angle, that little one, this angle.
I did find them. They're not finished. Do you want to ask? Because I can't get points on it. She held up. Oh.
Generally, if you talk to me, I'm willing to be
Thank you.
reasonable. Chapter 3, I won't be so reasonable. You got your one. Okay. So, this angle, they share that middle one. And this is not a line, so yes, this is adjacent again. And adjacent angles, the two small ones.
The big one is just 90?
In this case, it's 90, and in this case, it's 90. Yes, not always 90.
Okay.
One angle plus the other one. It doesn't matter which one you put first.
So
Just make sure.
So this is good.
Make sure you put a plus sign in
The
between
some
the rest.
things, I don't write them, say hi. Shut the door on them. Otherwise, my snacks will be quiet.
You were so locked in last week, lock back in. You can be added to the list. who is just about to make his pass because Diego is coming back.
No, I have that. Just hang out so we can get grades.
My bad, they just
Yep, I got that.
It's like,
Okay, so you're making the right one now? Okay.
She's not in my
All
office.
these ones that look like
I
this.
stopped it.
All these ones that look like this is Jason.
The one thing you don't know about adjacent though is what they add up to. That's gonna vary.
Yeah.
These ones, yes, these ones.
It is a square.
That's essentially what I was getting at. It's not always. These ones are.
The square, this is not a square.
The square tells you that 9 pounds. Cam, would you like my notes packet to get notes off of?
I think so.
I got 'em.
Okay.
Now it's equals each other. And this one is that one.
Dog is licking my toes every morning. I wake up and it's power and this her dog is licking my toes. Yeah, my son did. I took it out my boot, I saw that, and she's like,
Just so